Hey guys, these are the notes for parallel and perpendicular lines. This is the second part of the video over perpendicular lines. The first section was over parallel lines, and those are lines that never intersect. They have the same slope but never touch and they never cross. For perpendicular lines, they do cross. However, it's a special type of cross. It's not always just, hey, if they cross, they're perpendicular. In order for lines to be perpendicular, it does have to do with our slopes, right? So parallel lines have to have the same slope, but perpendicular lines have to have opposite reciprocal slopes. Okay, so let's talk about what that means. Oops. Okay, let's talk about what opposite reciprocal means. So opposite means opposite sign. So if it was positive, it's going to be a negative. And if it was negative, it's going to be a positive. So it's going to change to that or that. So it's opposite. And then reciprocal means you flip it. So if it's the original slope was 3 over 1, it is now 1 over 3. So you flip it. So opposite signs and reciprocal means flip. So let's do some examples here. I'm going to go ahead and do an example. If my original slope was 2/3, my new slope is going to be an opposite of that, so negative, because that was positive, and then you flip it, which is negative 3 over 2. Another example would be if I had negative 5 over 3. Oh, let's not do 3, let's do 4. Let's do a different number. If I have negative 5 over 4, opposite sign would be positive, and I would flip the fraction, it would be positive 4 over 5. So you have opposite reciprocals by flipping the sign and also flipping the fraction. And same thing with whole numbers. So if I have, my original slope was negative 2, my new slope, well, if you think about negative 2, that's technically over 1, right? Negative 2 over 1, those are the same thing. So if we have a slope of negative 2 over 1, it's going to flip and be positive, and now it's positive 1/2. All right. So I just kind of wanted to talk about that a little bit because perpendicular lines do have to have opposite reciprocals. So just because two lines cross does not make it perpendicular. They have to be perpendicular at 90 degrees. Okay, so let's just decide if these lines are parallel, perpendicular, or neither. So some of these might be parallel, some of these might be perpendicular, and some of them might be neither. So number 1, y equals x plus 5 and y equals negative x minus 12. Okay, so just like for parallel lines, we want this in slope-intercept form because that tells us our slope really easily. So we're going to do y equals mx plus b. We want it in that form. So number 1 is already in that form. Y equals x plus 5, that's going to be a slope of 1 or a slope of 1 over 1, right? So it's a positive slope. And then the second line has a slope of, let me go ahead and draw that 1 in. The second line has a slope of negative 1 over 1. So let's see. Are these perpendicular? Well, if I start off at positive 1 and I want to make it perpendicular, then I would have to change it to a negative and then flip it, and it'd be 1 over negative 1. So 1 over 1 but negative. So these are indeed perpendicular because their slopes are opposite reciprocals. And I'll go ahead and graph this one in Desmos for you. So we have y equals x plus 5 and y equals negative x minus 12. So these lines are perpendicular. They cross at a 90-degree angle. So they are perpendicular because their slopes are opposite reciprocals. Again, the opposite of positive 1 is negative 1, and then you would flip it. All right. Number 2. Well, the first one's already in y equals mx plus b form. Our slope here is negative 2. But our second one is not in slope-intercept form yet, so I'm going to go ahead and move, and I want my y by itself. So I'm going to subtract 2x on both sides. So I have y equals negative 4 minus 2x. So my slope here is going to be negative 2. And highlight my 2 here. My slope here is negative 2. So are my slopes exactly the same? Well, my slope for the first line was negative 2, and my slope for the second line is also negative 2. So these are going to be parallel because they're exactly the same. And let's check that in Desmos, right? So I know you can't use Desmos on a test or a quiz. However, it is a good visual tool to see, hey, am I doing this correct? So y equals negative 2x plus 3, forgot the y. And then we have 2x plus y equals -4. And this just happens to be in standard form. Hit my home button over here. So look, these are parallel. They never intersect and they never touch or cross. So number 2 is indeed parallel because both of my equations have the same slope. And number 3, y equals -4x plus 8 and -x plus 4y equals 9. Well, my first equation has my slope all by itself because it's in slope-intercept form. My slope here is going to be -4. However, my slope for the second equation is not in slope-intercept form, so I'm going to go ahead and move it. So I'm going to add x to both sides. So I have 4y equals 9 plus x. I want to divide everything by 4 to get that y by itself. 4 divided by 1 cancels because that's 1. And we have y equals 9 over 4 plus, now what number is technically in front of our x here? Technically a 1, right? So we have 1/4 x. So my slope here is positive 1 over 4. Let's look at our two slopes. I have -4 and then I have 1/4. So if I had a perpendicular slope with -4, let's check. If my original slope was -4, I want to write that as a fraction, so that'd be -4 over 1. If I wanted a perpendicular slope, I would have to change it to positive and also flip my fraction. So now it's a positive 1/4, which is actually what I have. So in this case, my two lines are perpendicular because our slopes are opposite reciprocals. Perpendicular. All right. Number 4 and number 5. So with equations like this, I like to look at them on a graph. However, the trick is if the letters are exactly the same, they're parallel, and if they're opposite, it's perpendicular. So let's go ahead and graph this one. I'm going to draw a little graph down here. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to graph y equals 8 in green. And since it's y equals, I'm going to look at my y-axis and plot a point at positive 8. And remember, this has a slope of 0, so you're going to have a horizontal line. With y equals 2, we're going to have a point at positive 2 on the y-axis, and this one is also going to be across horizontal. Remember, you want to follow those tick marks. It'll tell you the direction you need to draw your line. So these lines are parallel because their slopes are both what? Both 0. So remember, it makes a z for 0. So these are parallel. Their slopes are both 0. So that would be why they're parallel. Okay, so in the case that both of the numbers are not even opposite reciprocals and they're not the same and they're not really anything, then it would be neither. So it's either parallel and they have exactly the same slopes, it's perpendicular and they have opposite reciprocal slopes, or neither. So it doesn't matter. All right, I'm going to go ahead and draw another graph for number 5 to help me graph this one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so for number 1, it's y equals 3. And so that slope is going to be a 0 slope. And I'm going to plot that on my y-axis at positive 3. A 0 slope is horizontal. So the slope for this one is 0. For number 2, I'm on my x-axis at positive 2. I'm not going to use blue. Let's use this blue. I'm going to use darker blue. Okay, at positive 2 on my x-axis, I want to follow those tick marks. So that tick mark goes up and down because I have an undefined slope here. Or I have an undefined slope. Well, believe it or not, undefined slopes and 0 slopes are opposite reciprocals. So the opposite of a 0 slope would be an undefined slope. So in this case, this would be perpendicular. Go ahead and move this because it's kind of, oops, whoa, that is not what I wanted to happen. Boop. Okay, so these are perpendicular because they are opposite reciprocal slopes, even though it might not seem like it, but they are. And the reason why they are is because they are opposite of each other, because it's hard to say the opposite of 0. Perpendicular. Okay, I'm just making sure I'm spelling these things right because spelling is hard, guys. Spelling is hard sometimes. Okay, moving on. So do these graphs contain perpendicular lines? Well, again, we can't just assume. Just with parallel lines, we can't just assume by looking at it and being like, hey, they cross, must be perpendicular, or hey, they don't cross, must be parallel, right? You have to actually check your slopes. So For this one, for parallel, I gave you a note that said they need to be the same slope. Well, here they need opposite reciprocals. Remember, opposite means different signs. So if it's positive, you need the other one to be negative. And if one's negative, you need the other to be positive. Reciprocals mean you just flip your fraction. So if the slope is 3, then the new slope for perpendicular would be negative 1 over 3. All right, so this first line over here I'm going to do in red, and I'm going to start at this point. So we have to do rise over run for graphs. So I'm going to go ahead and write that note in the middle, put a little sun around it so we remember. Okay, so rise over run. So my slope here, I'm going to have my rise over my run. So my rise here, well, I can't rise, so I'm going to go down. I'm going to rise down negative 2. And you know what? This is bothering me how close it is. Let's do this over here. So negative 2 is my rise, quote unquote, and then my run is positive 1. So my slope here is negative 2 over 1 for that line. And the other line I'm going to do in green, which is going to be this one, and I'm going to start in this point in the middle. Again, it does not matter what point you start at. So I'm going to go up 1, so plus 1 for my rise. So my slope is so far 1. And then I'm going to run positive 2, so 1 over 2. So are these slopes opposite reciprocals, the same, or neither? Well, these slopes are opposite reciprocals. Remember, opposite means different signs. Reciprocals means you flip your fraction. So since these are opposite reciprocals, these are indeed perpendicular. Now let's say you had a slope of like negative 3 and positive 2. Those are just neither because they're not the same and they're also not opposite reciprocals. All right. I'm going to go ahead and do one of my lines in orange. I'm going to do this one in orange. So I'm going to go ahead and start with, let's do this point down here. Okay, so I'm going to do my rise over run. My rise is going to be plus 1. My run is going to be negative 1 because I'm going to the left. So my slope here is 1 over negative 1. Or just negative 1 over 1, right? Because it's the same thing. Or negative 1 over 1. Okay, my other slope I'm going to do in purple. Is that okay? Have I used purple yet? Not yet. So this slope, I'm going to start with this point here. I'm going to run or rise up 2. So my slope so far, is it up 2? Yeah, 2 plus 2. And I'm going to run also to the right 2, so it's also a positive 2, which simplifies to 1 over 1. Well, looking at my two final slopes, I have 1 over 1 and I have negative 1 over 1. Well, these are opposite reciprocals, and they are, they're not opposite reciprocals. They are opposite reciprocals, meaning they have opposite signs, and you flip. Because 1 over 1 flipped is just still 1 over 1, except the other one has to be negative. All right, so these are also perpendicular. Let's go ahead and highlight our slopes here, 1 and negative 1 over 1. And then we have a slope of negative 2 over 1 and 1 over 2. All right, now we're going to write an equation of so we have 3 word problems, I think. Writing equations of perpendicular lines. So we're going to write equations that contain perpendicular lines. So write an equation of the line that passes through the point negative 2, 3, and is perpendicular to y equals 1/2 x minus 1 in all 3 forms. So just like with any equation, you always want to start in point-slope form. In order to have point-slope form, I need a point and a slope. So, well, I want to underline perpendicular. That is a key word. The most common mistake we make is that we want to make every single line parallel, and we can't do that. Perpendicular lines have opposite reciprocal slopes. So make sure you have opposite reciprocal, and you write it down or write something down to be like, hey, don't have the same one, the opposite one. Okay, and it's opposite reciprocal to this purple line, which is y equals 1/2 x minus 1. Well, my slope here, so the original slope, original m, is going to be 1/2. But I need my new slope because I have a perpendicular line. Perpendicular lines have opposite reciprocals. So the opposite of a positive 1/2 would be a negative number. And then instead of 1/2, now I have 2 over 1. I flip it, which is the same thing as negative 2. This is the one I want to use. So I don't even care about my original anymore. I just care about the new slope. My new slope is negative 2. Do not use the old one. It is the most common mistake people make. All right, so we're going to start in point slope form. Y minus y1 equals x, or m times x minus x1. And I want to go ahead and bring out my point here. I want the new line to go through the point -2, 3. So I have the point -2, 3. Go ahead and write my point here. -2, 3. Move all this stuff down a little bit. Now my point is going to give me what point I need for my point slope form. So that's my x1 and my y1. So my y1 here is going to be -3 because it changes the sign and it flips it opposite. My m is my slope, and you make sure you use the new slope, the slope that's going to make it perpendicular, which is going to be -2. And then we have x, and we're going to have +2 because we flipped the sign for our x1 here. Okay, so that's my point slope form. Okay, now the next form you always move into is slope-intercept form. So I'm going to go ahead and copy down my slope-intercept, or copy down my point slope so that I can start moving into slope-intercept. Again, I like to color code for you guys, so that's why I do the things that I do. All right, in order to get this in a slope-intercept, the first thing I got to do is distribute. -2 times x is going to be -2x. -2 times 2 is going to be -4. The next step I'm going to do to get y by itself is add 3 to both sides. I have y equals -2x minus 2. Is that right? Just kidding. -1. Okay, I'm like, what did I do wrong? Okay, so that's my that's my slope-intercept form. Now from slope-intercept form, we're going to move this into standard form. Standard form, again, is ax plus by equals c. And we can have no fractions or decimals. And we want a to be positive, and we want, whoa, what did I do here? I forgot an equal sign, huh? Equals -2x. Okay. Standard form, I want x and y on the left side. I want my a to be positive, and I want no fractions or decimals. So the first thing I'm going to do in order to get this in a standard, I'm going to add 2x to both sides. I have 2x plus y equals -1. I want to always write my x first. And here I already have standard form. My a is positive, it's a +2. I have no fractions, and my x and y are on the left side, so we're good. And just like parallel lines, my green, my blue, and my pink lines are all equivalent. They're just written in different forms, right? They're all the same, they just look a little bit different. So let me go ahead and plug those all into Desmos to show you and just remind you, hey, these are all exactly the same. So we have y minus 3 equals -2 times x plus 2. So this is our point slope form, which I'll change to green to match what we have on our notes here. Our slope-intercept was y equals -2x minus 1, and that was in blue. And then in pink, which I'm going to have to use red because I don't have a pink on Desmos, was 2x plus y. Was it plus y? Yeah, it was plus y equals -1. And I'm going to go ahead and change that to red. If I click through all three forms, if we look at them, they're all the same line, correct? I can zoom in and be like, hey, red, blue, green, they're all exactly the same. So again, all equivalent forms. Now let's see if this is actually perpendicular to our original line, which is highlighted in purple, which is y equals 1/2 x minus 1. Y equals 1/2 x minus 1. Again, my red, my blue, and my green are all the same line. So I actually can delete one of them. I'm going to go ahead and delete my point slope and my slope intercept and just look at my red line, which is my standard form. If I look at my red and my purple, they are perpendicular to each other. Oh my goodness. Sorry, I'm like dragging. There we go. They're perpendicular to each other. They cross each other at a 90-degree angle. And I can check to see things are perpendicular if they have opposite reciprocal slopes. So for example, in point slope here, I have a -2 as my slope, okay, for my point slope. My original line had a slope of 1/2. So those are good because those are opposite reciprocals. Opposite is opposite sign, reciprocals means you flip the fraction. I know I'm sounding like a broken record, but it's perpendicular and parallel lines are just something that we struggle with, and I'm just trying to make sure you understand, hey, this is what we're doing. Don't use old slope, opposite reciprocal. All right, so moving on. Number 2 is the same thing. We're going to have extra practice writing a perpendicular line to another perpendicular line, or a perpendicular line to an original line. All right, so here we need to write an equation of a line that passes through the point -3, 2, and it's perpendicular to x minus 2y equals 7 in all three forms. So go ahead and look. We have perpendicular, which means we need opposite reciprocal slopes. Okay? We don't want to keep thinking like, hey, it doesn't matter. It does matter. Your slope has to be opposite reciprocal. Okay, so let's look at our original line here. Our original line here is x minus 2y equals 7. However, that's not in slope-intercept form, so I don't know what my slope is. So I'm going to go over here and change it to slope-intercept form. Remember, we want y equals mx plus b. That's the easiest form for us to identify a slope in. So I'm going to go ahead and I'm going to subtract x on both sides because I want to get y by itself for slope-intercept. Okay, now once I'm here, I want to make sure I divide everything by negative 2. Negative 2 divided by negative 2 is positive 1, which cancels. And y equals negative 7 over 2. And then the number in front of our x is a negative 1, right? So we have negative 1 divided by negative 2, which is going to give me a positive 1/2. Remember, a negative divided by negative is a positive. So our original slope, original m is 1/2, because that's what we have here, 1/2, a positive 1/2. That means our new slope, our new m, is going to be the opposite sign, which is a negative, and the opposite of 1/2 is 2 over 1, which is going to be negative 2 over 1, or just negative 2. So our new slope here is also negative 2, kind of like the last problem, so that's pretty cool. All right, so you want to use that new slope. Forget about the old slope. Don't worry about it anymore. Oh, my Notability crashed, so let me go ahead. It wasn't writing anymore, so I had to undo that. Okay, you want to use your new slope. Do not use the old one. If you use the old one, you're making a parallel line because they will have the same slope. So make sure you're doing perpendicular. Okay, now we have a slope, and we always want to start in point slope form. However, I have a point as well, so make sure we talk about our point. Our point here is going to be the point negative 3, 2. And we always want to start in point slope. Remember, point slope is y minus y1 equals m times x minus x1. And so our x1 is going to be negative 3, and our y1 is going to be positive 2. But when I plug it into point slope form, remember my signs are flipped. So I'm going to have y minus 2, because it's my y value, equals m. Remember, use your new slope. It is perpendicular. We underlined it in red. You're going to use the new slope of negative 2, and then you're going to have x plus 3. Okay, so that's in point slope form. And I want this in slope-intercept and standard as well, so I'm going to go ahead and start my process for making slope-intercept. Okay, the first step I'm going to do is I'm going to distribute. So I have y minus 2 equals negative 2 times x, which is negative 2x, and negative 2 times 3, which is negative 6. And then I'm going to add 2 to both sides to get y by itself for y equals mx plus b. Y equals negative 2x minus 4. I know I'm talking quite fast, but I know this is a video, so you can always rewind if needed. So my slope-intercept equation is y equals negative 2x minus 4. But still, it's the same form or the same equation as my green point slope one. It's just written in a different way. Now I need my standard form. So standard form down here is ax plus by equals c. We want our x and y on the left, a to be positive, and no fractions or decimals. So I'm going to go ahead, whoops. I'm going to go ahead and copy this one down back in blue because this is still slope-intercept. And now we're going to begin the process of making it standard. So I'm going to go ahead and get my x and y on both sides, or on the left side. So you have 2x plus y equals negative 4. Well, x and y are on the left. I have no fractions or decimals, and my a is positive. So this is already in standard form, and I don't have to do anything extra. Okay, so let's check in Desmos to see if our green, our blue, and our pink lines are all actually equivalent to each other. So I'm going to go ahead and type these all in. Our green one is y minus 2 equals negative 2 times x plus 3. Make that green because that was our point slope. Our slope-intercept form was y equals negative 2x plus 4, minus 4. Minus 4, and that was in blue. And then our standard form was 2x plus y equals negative 4. And then we're going to make this red, because we don't have pink, right? Hit my home button real quick, and if I tap between all 3 lines, I notice that they're all exactly the same. They all are the same line, so that means I converted correctly. Now let's check to see if it's actually perpendicular to the original line, which was x minus 2y equals 7, the one that's highlighted in purple. I'm going to go ahead and get rid of both of my other lines and just have my point slip line here. We have x minus 2y equals 7. Oh, excuse me. Okay, so I'm going to make this purple. Now if I look, yeah, they're perpendicular. They cross at a 90-degree angle, and they have opposite reciprocal slopes. So if your slopes are exactly the same, they're going to be parallel. If they're opposite reciprocals, they're going to be perpendicular. And if it's like -3 and like +2, then it's neither, right? It doesn't do anything. All right, so that is writing that. And we have one last problem. Determine if the following lines are parallel, perpendicular, or neither. Now, I'm going to go ahead and number my lines here. The first line, I'm going to number it as number 1. The second one will be number 2. And the third one will be number 3. Okay, so I have 3 lines. Now we always want to compare if lines are parallel, perpendicular, or neither by looking at the slopes. So number 1, it is very evident to me what my slope is. It's -5 because it's already in y equals mx plus b form. However, the second line, number 2, is not in slope-intercept form. So I'm going to go ahead and begin the process of making it slope-intercept. So I'm going to copy it over here. -15. Oops. Okay, I'm going to begin the process of putting it in slope-intercept form, and y by itself. So the first thing I'm going to do is I'm going to subtract x on both sides. And then I have -5y equals -15 minus x. And then the next step I'm going to take here is I'm going to divide everything by -5. Everything. -5 divided by -5 is a +1. And I have y equals -15 divided by -5, which is +3, because a negative divided by negative is a positive. And then I have -1x over -5. Remember, there's technically an imaginary 1 in front of that x. But a -1 divided by a -5 is going to give me a +1 over 5. Because remember, a negative divided by negative is a positive. So, the slope for my second line is 1/5. And actually, I'll even go ahead and number them into the colors that they are. So number 1 will be in blue. Number 2 would be in green. And let's make number 3 red. Okay, well, number 3, I need to, I'm going to start this one. I'm going to say that's red, so I'm going to do that down here. This is also not in slope-intercept form, so I'm going to go ahead and move it into slope-intercept form. Your goal is to get y by itself. So the first thing I'm going to do is subtract 5x on both sides. Y equals 7 minus 5x. And this is already in slope-intercept form, so it's pretty nice. So my slope here is going to be -5 or -5 over 1. Go ahead and write that as a fraction just so that it's a little bit easier for me to compare things. All right, so I have 3 slopes here. I have -5, -5 over 1, and then 1 over 5. Again, this is still the same thing as -5, and the same thing with the first slope. That's also -5 over 1. So they're all kind of the same thing. All right, so let's compare. Are any of these lines parallel? Well, if I'm looking at my blue line, I have -5. Do I have any other lines that have a slope of -5? Yes, my red line. So the blue line has a slope of slope of -5, and the red line also has a slope of -5. So 1 and 3, or lines number 1 and number 3, are parallel to each other. They have the same exact slope. Okay, do we have any that are perpendicular to each other? Well, that means they have opposite reciprocal slopes. So what's the opposite of -5 over 1? I'm looking at my blue line. The opposite of -5 over 1 would be positive, and then the flip of that would be 1 over 5. So I need +1 over 5. Do any of these lines have a slope of +1 over 5? Yes, the green one. So that means that my first line, my blue line, which is the slope of -5, has a opposite reciprocal slope of 1/5, and the green line happens to be that slope, 1/5. Okay, and I also have one more pair of perpendicular lines. So if I look at my red line, I have -5 as my slope, or -5 over 1, which is the same thing as my blue line, right? These are both parallel. That means that my green line must also be perpendicular to my red line since it was parallel to the blue one. I know, that's a lot of like, whoa, what did she say? So if 2 lines are parallel to each other, then a line perpendicular to one of them has to be perpendicular to the other as well, just by, the pigeonhole theory, which is like, if it happens here, then it's going to happen there kind of thing. I might have used the pigeonhole theory wrong, but that's okay. Okay, so if we're looking at the red line, I have a slope of -5 over 1. Well, the opposite would be positive, and I would flip it and make it 1/5. So -5 over 1 would flip to +1 over 5, which happens to be my line 3 and my line 2. So those are all of my pairs. And none of these are going to be neither because it's not like we have a random line in there. So for example, if line 4 had a line of had a slope of -2, then that would be the one that was neither with everything else. All right, so these notes were pretty lengthy, and I will say that parallel and perpendicular are things that we struggle with. So if you have any questions, always feel free to come in and ask. I am always welcome to help.